Now, let us start a new topic. Let us start a new topic. Steady state error analysis. So my friend, if you are joining us for the first time in this lecture, make sure that you have subscribed to this channel and make sure that you watch the earlier covered lectures, because that is where we have covered transfer function, signal flow graph, transient analysis, and now we are starting a new thing, that is the steady state error analysis. Okay, steady state error analysis. Okay, is that clear? Okay. Now, let us first understand, guys, what is the practical significance of this topic. What is the practical significance? See, steady state means when the output settles down to a final value, right? That is what the steady state means. When we started time response, I clearly explained to you the physical significance of transient and the steady state. So, steady state is when the output settles down to a final value. Now, if that final value is the desired value, then very good. But if it is little bit different from the desired value, then that deviation, that difference is called as the steady state error. Like, let me take a real life example. Okay, let me take a real life example. Right now I am sitting in my studio. I am taking your class. My AC, I have set it at 22 degrees centigrade. But literally, let me tell you, I am feeling very hot. Okay, the heat is basically the heat is high in this room, and that is why the temperature is high. And I am not feeling very comfortable in this temperature. So that means if the AC does not cool the room anymore, then the temperature at which this room is settled is different from my desired temperature. अगर मैं टेम्परेचर 22 लाना चाहता था और AC ने 24 लाके छोड़ दिया, तो 2 डिग्री सेंटीग्रेड का डेविएशन है, और ये 2 डिग्री सेंटीग्रेड क्या है मेरे दोस्त? That is called as your steady state error. That is called as your steady state error. Okay, similarly, suppose I take part in archery or I take part in shooting. Then I'll have a target where I have to focus and where I have to shoot. Now, if my dart directly strikes at that point, then it is good. But if it does not strike that point, that means there is an error between the value that I was targeting and the value that I obtained. Okay, are you able to understand what is the steady state error? Steady state error is the deviation of the final value of output from the desired value. And you will see this steady state error in all aspects of your life. Suppose someone, let us say someone wanted to get a rank, let us say 10 rank, and he is able to get the rank 12. Then there is a 2 AIR difference, that is the steady state error. Okay, so let me tell you. Suppose let me take an example from a student attending this batch. Let us say Shivam is there. Okay, Shivam is there. Let me say his desired marks in GATE 2021. Let me say his desired marks in GATE 2021 are, let us say, 85 marks. Let us say 85 marks. Now, his mock test performance is like 50, then 55, then 62, then 70, then 65, then 64, then 71, then let us say 75, then let us say 82. These are his mock test performance. Now suppose he gate result as let us say 84 marks. Okay. Now this behavior, this is your transient, and this is your steady state, the final score that he gets, and the error is basically 1 mark. Now you understand the significance of the steady state error. What is the difference between steady state and transient, and how is steady state error relevant? Another example, let us take in case of instrumentation or measurement. Suppose I want to measure a current. That current is 5 ampere. Now due to certain error in the instrument, the instrument measures 4.8 ampere. Then that 0.2 ampere is your steady state error. Let me take another example. Let me take an example of a ammeter. Ammeter, my friend. Suppose this is the display. 1, 2, 3, 4, 5. It is a 10 ampere range ammeter that can measure up to 10 ampere. Okay, this is the ammeter. Now initially my pointer was at 0 position. Now the current that I apply, applied is 5 ampere that I want to measure. So how does my pointer behave? If it is a second order system, my friend, this pointer will go, but it will cross this steady state. It will go up to here. This is the peak overshoot. Then it will oscillate like this, sometimes here, sometimes there. So it will oscillate here like this, again and again, but the oscillation will keep damping out, and let me say the final position is here. Okay, then this difference in the reading is your steady state error. Are you able to get this, my friend? The pointer starts to move from the 0, but it crosses the desired, then comes back, then again crosses, comes back, gradually settles down. So that pointer deflection again and again, that is your transient, and when it finally settles down, that is your steady state. But if that value is different from the desired value, then we get a steady state error. So now you understand how we are relating the transient and the steady state response. What is the significance of transient and the steady state in the actual practical life? This you need to understand. This is very, very important, how this concept is related to your real life application. Okay.